Welcome. Let us talk today about the nuclear technology in hydrogen economy. As the subject is really too interesting. What we present before was about the normal hydrogen. But really, the hydrogen has three isotopes. The first one is the normal hydrogen. Second is the deuterium. Third is the tritium. Once we talk about the nuclear technology and hydrogen economy, for sure we will bring the other isotopes, I mean deuterium and tritium, to discussion. Okay, this is first. Second, there are several types of reactor may support the hydrogen economy. The first one we discussed today is a CANDU reactor. We will talk about its design, advantages, and disadvantages as well. First, about the design. Generally, we may spoke before about the design of nuclear reactors and how they work. The CANDU reactor is a pressurized water reactor with some differences. Can mean Canadian, even you may find it in another countries. More than 12 reactors have been built outside Canada. China, Romania, Pakistan, India, and so on. D means deuterium. So CANDU reactor is working with heavy water, not with light water, like the traditional pressurized water reactor. U means uranium. Even CANDU reactors are working also with thorium fuel and spent fuel of the light water reactor. Okay, this is about the meaning of CANDU. This abbreviation itself as a CANDU reactor. Canadian Deuterium Uranium Reactors. Okay, so as we said, CANDU reactor is a pressurized water reactor working with heavy water, which is deuterium oxide, as coolant and moderator. The heavy water is higher in neutron absorption than the light water. Okay, also it is more stable than the light water in thermal and electrical properties. This stability makes the reactor itself more stable than a light water reactor. Second, the high neutron absorption of heavy water makes it suitable for this type of reactors. Okay. So this is about the heavy water. Second difference between CANDU and light water reactors, pressurized water, normal pressurized water reactor, is the design of the vessel. The vessel itself is horizontal, calandria. This calandria is a multi-layer where there are special channel for fueling and fuel removal. So fuel installation and de-installation in CANDU reactor is different, and this is a unique feature in CANDU. This fuel channel, okay, cladding fuel channels and calandria are different. Let us talk about the advantages of CANDU reactor. The first advantage is the working with natural uranium-238, so there is no need for enrichment. Second, working with heavy water, and heavy water is more better than light water in nuclear reactor due to some reason. Some of them is the stability. It is more stable than light water. I mean the thermal and electrical stability. Second, its absorption of neutrons is higher than the light water. Okay. The third advantage of the CANDU reactor is the fueling online. Generally, we can fuel the CANDU reactor online during working cycle. So it is very simple compared with the complicated process and time-consuming fueling techniques in normal pressurized water reactor. Number 4 is the production of more fuel than what this reactor consumes. It is now, we discuss it as privileges or advantages, while it will be considered also as a disadvantage or contra later also. The production of cobalt-60 is number 5, while cobalt-60 isotope is used in medical and sterilizing application. Production of tritium. We start with CANDU reactor with the production of hydrogen, then production with the deuterium to get heavy water. Third, the heavy water or deuterium oxide, the deuterium itself is converted into tritium inside the reactor. Number 7 is the production of hydrogen. The content of the heavy water and light water is 1/6,000. So the cascaded thermolysis or electrolysis techniques of water produces at the end heavy water. So during the production of heavy water, we get hydrogen as well. Okay, this is one of its unique advantages. So this is behind the reason of adopting CANDU reactors in hydrogen economy. Okay, the passive safety. Once the heat gets above the normal or rated value, the fuel channels bend and stops the nuclear reaction. So the CANDU reactors apply the passive safety in early stages before this concept being developed in generation 3 and 4 of nuclear reactor. Also, number 9 is working with all types of fuel. CANDU reactors can work with uranium, thorium, and spent fuel of the light water reactor. Number 10 is a horizontal vessel, and I find it a very good advantage of CANDU reactors. While it's better than the traditional pressurized water reactor with vertical vessel. So the horizontal calendria gives the operator more a chance to get the reactor under control. So the control was come in a vertical arrangement, while the fuel channel are horizontal, by which we distribute the control, cooling, fueling system of the reactor over the different dimension of the reactor, not only from the above. As in fact, I hate this vertical vessel design of traditional pressurized water reactor. Everything from the above to fueling, control road, emergency road, cooling, poisoning are from the top of the reactor. Once you get accident, the reactor explodes from this area. I mean the above of the reactor, where in LUCA accident, loss of coolant accident, the water split into hydrogen and oxygen, and the hydrogen is collected in this upper area, and at very high temperature with a fission chain reaction, the reactor is converted into hydrogen bond. Okay, these were the advantages, 10 advantages of CANDU reactor. First is working with normal uranium-238. Second, working with heavy water. Third, fueling online. Fourth, producing of more fuel than what it consumes. Fifth, production of cobalt-60. Number 6, production of tritium. Number 7, the production of hydrogen in general. Number 8, the passive safety. Number 9, working with all types of fuel. Number 10, the unique horizontal vessel. Okay. Let us talk about the contra or disadvantages of CANDU reactor. The first disadvantage is the size of the reactor. So the most appropriate size of the CANDU reactor is the small and medium size. And this is disadvantage and advantage as well, as we will see in our discussion on a small modular reactor. So it is a very good idea to have medium size. It is about 700 megawatt. And take care, the size in nuclear compared with the size in solar is different. So we talk about kilowatt as a small solar station, medium with mega, and mega station with over 10 mega or 100 mega, called large solar station. But the size in nuclear reactors is different. We speak about small nuclear reactor, about 300 mega or less. So this is small, exactly as you compare small elephant with small cat. Exactly the same comparison between nuclear and solar. The medium size in nuclear means 700. Large size reactor or mega reactors are about over 1,000 mega, over gigawatt. Okay, so this is difference between nuclear and solar inside. The second disadvantage is the proliferation or production of plutonium. In fact, the nuclear technology is restricted by the political confrontation worldwide and misuse of this technology in military applications. I think the future will be more peaceful, and the military activities in nuclear industry will be prohibited, and this industry will be devoted to support the peaceful applications only. But consider that the production of limited quantity of plutonium is not critical at all, because it is only about 5% of the fuel. Second, the production of fuel and recycling of spent fuel and the nuclear waste is authorized for limited authorities worldwide. So it is not dangerous at all compared with the normal pressurized water reactor, because the pressurized water reactor working with light water is working with enriched uranium, maybe up to 20%. Okay. Third, it is for sure expensive to get the design itself. The design itself is more advanced and more expensive than the light water reactor. Also, this cost is considered in heavy water. The heavy water is more expensive than the light water. So these were the disadvantages of CANDU reactor. The measure 3 of them is a possible proliferation, I mean the production of plutonium. Second, this type of reactor is limited to medium and small size only. Third, this type of reactor is more expensive than the others. The small modular reactor. As we said, the word small means 3 mega or less in nuclear reactors. The small modular reactor is preferred nowadays to avoid the problem of the reactor accident, especially the LUCA accident or loss of coolant accident. Okay, once we shut down the reactor, we don't reach 0% power. The residual heat or power of the reactor is about 2%, from 2 to 4%, around figure. Okay, and if you imagine a reactor over 1,000 megawatt or 1.4 megawatts, the residual power will be huge. Could be 20 mega or more. It means 20,000 heater, like the water heater of your home. 20,000 are working as a residual and remainder power level. So it is dangerous to get the reactor under control in this case. So building a large size nuclear reactor exactly as raising elephant or lion as a pet at home. It's not wise at all. You may build a huge or giant tower or a mega bridge or something like that. But it is not wise at all to build a large size reactor. The recommended size of nuclear reactors, according to my opinion, is a small size. The word modular here means we can produce all units and components of the reactor in an industrial company, then we can simply transport it to the location of installation. So just we get the commissioning, installation, after that, modification, change, or maintenance will be easy, as well after decommissioning and deinstalling or disassembly the reactor itself will be easy, where the component can be simply assembled and disassembled after commissioning and decommissioning of the reactor. It could be easy as well in the waste recycling of the nuclear reactor later, as the nuclear industry went out of this narrow position in military activities and application. I think the nuclear industry can get huge and massive advances if we just get it out of this critical positions, political confrontation, and the military application. But I'm sure that the future will be more peaceful, inshallah, because the world will be just a small electronic village after the development of the internet. The people are more connected, and the peaceful applications of the nuclear industry will be more powerful. Okay, this is about the size and modularity of the nuclear reactor. The last point to talk about today is the thorium reactor. Generally, uranium fuel cycle continues for 2 to 3 years approximately, while the lifespan of the thorium fuel is about 30 years. If you consider the lifespan of nuclear reactor as 60 years, so we will change the fuel only 2 or 3 times during its commissioning, from commissioning to decommissioning period. From the start to the end of the reactor lifetime, we will change the fuel just 2 or 3 times. It means we will reduce the nuclear waste as well. Also, don't forget a big problem in the nuclear industry is the limited success in recycling. So if we design the nuclear reactors as modular components or modular units, we should also describe from the beginning of the fabrication of production how can we recycle these products or these parts of the nuclear station. I think this area will get a lot of interest in the future. The peaceful application will get more advances and more power, and the military application and the production of mass destruction weapons will be eliminated and avoided. The world becomes more connected, and the people now are in a strong relation by which the peaceful application will be disseminated easily and normally in the future. Thanks a lot.